Hello everyone! A couple of weeks ago, I published an article about how model context protocol servers can give superpowers to smaller language models by abstracting away the complexity for the model. In today's demo, I want to give some real-world examples on how to make this work. I'll be using the IBM Granite 3.2 models, which have 8 billion parameters, so we can consider them smaller, and the Kubernetes MCP server. So these are the key aspects to make everything work. Basically, the MCP server needs to provide well-defined high-level functions that perform most of the low-level tasks for the model. If you check most of the MCP server implementations, they are usually wrappers around CLI tools. They provide lower-level imperative functions to the LLM. This is mostly fine for large language models such as Claude, but they don't work that well with smaller language models. Claude, for example, has the knowledge to create Kubernetes resources, YAML files, or to call a given CLI tool, and so on. But the smaller models, at least those that haven't been fine-tuned, might not have that knowledge available. They are dumber. So I think that the Kubernetes MCP server is a very good example because it provides both the lower level functions that are helpful for large language models like Claude, but also higher level functions that abstract away this complexity for the model. We will see that next. In addition, it's very important to provide a very good system prompt. So you need to know your model, right? So for example, for the IBM Granite 3.2 models, the IBM documentation provides some tools or some tips on how to actually implement this prompt. So you should follow these recommendations and also experiment with different prompts until you actually make the model work with your functions. In addition, you also need to know your inference servers. So for example, with Ollama, you need to know how the model provides the responses in order for Ollama to be able to parse the function calling. So if your model is actually calling a function, it should provide the response in a given format that's parsable by Ollama. So enough talking, and let's actually see this in action. So here in my right, I have a ChatGPT, local ChatGPT implementation that has the Kubernetes MCP server loaded. And on my left, I have the view of my OpenShift demo cluster. So I'm going to ask Granite to list all my pods. So as you can see, the model called the function pods list, and it actually replied with a markdown formatted table with the pods that are running in this cluster. So yeah, this is kind of simple, but let's ask it to run a pod. So run a pod with Okay, so this is a much more involved functionality because it would actually, if you were actually only providing the lower level function to create a Kubernetes resource, then the model would actually need to know the YAML syntax for a pod, or maybe for a deployment, the service, the route, and so on. However, the Kubernetes MCP server provides this pods run function that will actually create the pod, the service, even an OpenShift route, just by providing the image name and the port that you want to expose. So it's actually abstracting away all of this complexity from the model and making any model, even these dumber ones, being able to deploy this application. So as you can see, everything is running fine. We can ask it to delete this pod. Yeah, and you can see, the server, the LLM, the smaller model, could actually delete the pod and also all of the resources that were created, because like the Kubernetes MCP server provides all of this functionality for the model. The other part that I was talking before is like the importance of the system prompt. So here I have a Vercel AI example running in, this is JavaScript, but you could do the same with Python or with whatever. And here what I have is the configuration for my MCP server. It's using the Kubernetes MCP server. And then my connection to the Granite model, right? So here is the system prompt, which I did following the IBM recommendations. And well, I fine-tune it a little bit, but yeah, it's mostly following those recommendations. So if I ask it to list my running pods, like this, yeah, as you can see, it actually calls the tool pods lists and outputs the pods using this markdown syntax. However, if I change the system prompt, let's say I'm simplifying it, so you are just a helpful assistant. If I run this again, so in this case, instead of calling the tool, it just provided some sample output and like an explanation of what it should be doing. So as you can see, the system prompt is really, really important. Okay, so this is all for today's demo. You should now be able to make those smaller models perform better and save on your inference costs by using them instead of the more expensive larger models. I hope you like the demo.